So even though I am designing a biasing circuit, how can I say the circuit is efficient enough? How I need to have a mathematical parameter to ensure to say that my circuit is efficient in stabilizing the Q point of my circuit, right? So that is quantified by a term called as stability factor. So even though you put lot of effort studying subjects every semester, finally, how will you quantify the efforts what you have put at the end of semester? You will be conducting exams and you will be evaluated and you will be given a GPA at the end of semester, right? So the GPA will say that what is your capability. I'm not saying that GPA only will say about your capability. No, GPA to an extent can give an idea about your capability. So you are strong in so and so subject. You need attention in so and so subjects. So same way in a transistor, even though after designing all the biasing circuits and fixing the Q point exactly in the middle, I just need some parameter to say yes. If this parameter has some value, I can say the transistor is working well. Otherwise, I can say the transistor is not working well. So that mathematical parameter is called as stability factor. So we have three stability factors denoted by S, S dash, and S double dash. Why we need to have three stability factors? Can anybody say? Why can't we have one parameter and we have three stability factors? S, S dash, and S double dash. Wild guess. Anybody can make a wild guess here? Can anybody say what should be the reason for having three stability factors for a single transistor? The answer is known to you. How many parameters vary with temperature in BJT?
Three.
Three, sir.
Three. What are they? IC naught, beta, and
IB.
IB or VB. So for accounting for the variation of each parameter with respect to temperature, I am going to have three separate stability factors, nothing else. So there is no other reason. It is logical to have three stability factors with respect to each varying parameter. And one thing, remember, because of variation in all the three parameters, what is the effect in transfer because of all these parameters varying with respect to temperature? My collector current is going to increase. That is the ultimate effect because of all the variation, whether it is going to be IC naught, whether it is going to be beta, or whether it is going to be VB. So I am going to check the variation of IC with respect to all these parameters, IC naught, beta, and IB. So when I say variation in mathematics, I use the term differentiation for checking the variation.